Okay, could you please take your seats? We want to continue. Just one more point on the feedback sessions we just listened to. I think there were a number of points that we as EASA will have to work on, and we will make sure that we follow on with the recommendations or actions that you highlighted. The next topic is more of a technical topic, but also at the same time something that you as DOAs have to address. And it's about additive manufacturing and how you as DOAs have to address things. And I would like to ask Alexandru Inache and Wolfgang Hoffmann to do this presentation. Thank you.
Good morning. I hope you had a good coffee break and some nice discussion with your colleagues. Yes, we are here today, this morning, to try to provide you some information on additive manufacturing and some DOA aspects related to this. First of all, thank you for proposing this topic to the agency for this workshop. The survey we ran before the workshop, in this survey, the additive manufacturing scored quite high, so that's why we are here today in front of you. How we built this presentation? Together with Wolfgang, who is structural expert in large airplanes department. We thought to have two parts. The first part, Wolfgang will go with you through some technical aspects of additive manufacturing, including challenges, including the EASA strategy, some events we are organizing on this topic annually. Also, he will present you some developments in the area of industry standards and some available guidance material. In the second part, I will touch on some DOA aspects, type design, material specification, process specification, interfaces, in particular with production organizations, and also what is the impact on DOA if we have a significant change or not, when a DOA is contemplating starting additive manufacturing activities. And in the end, some closure remarks. So I will invite now Wolfgang to go with you through the first part.
Thank you, Alex. So just I have to take a deep breath because a lot of people here. And I would say, let's put the focus on you first. So may I ask a question to you? So how many of you can raise your fingers, have to deal with the additive manufacturing technology currently, or, okay. Okay, well, it's somehow congruent with our general observations. So, but I think I can focus a bit more on the first 3 introductory slides, which are more technical, to explain what it is. So what you see here, I'm afraid it's not a good quality, but you may see this is a kind of CAD system which is building up layer by layer the electronic part. And so it doesn't take so much time, but you see the part is being built up in an electronic way. And with the additive manufacturing technology, we can do it with hardware. So this is a big difference. It takes a bit more time than just doing this via bits and bytes, like here in the picture. But there are different technology. They have all one in common. This is, you have meltable material or fusible material, and you will melt it layer by layer and build up the part after a certain long time. Different technologies for this are available, so you can do this with laser melt techniques. A laser is melting material, or with an electron beam. So electron beam is also melting the material. You have just in detail slightly different possibilities with the methods and advantages and some disadvantages when you compare them. And so we go just to the next slide. When we see this technology, it's quite nice actually. You have kind of starting material, feedstock material we call it, which is mainly metallic or polymers. You can get it in form of powder or in form of a more solid wire or piece of plastic, and all this will be melted in the second process in a machine, which you see there, which shouldn't be somehow a black box. It should be more a white box like it is depicted here. So with white box I would like to express you should know what the machine is doing in detail, because it may have influence on your material which comes out after on structural strengths or fatigue properties. So, and then finally, after the print process, you will have some nice shiny parts. They're looking good, just ready for installation, you would think. But this is not really the case, so you would have to do some post-processing for this part. So that means surface finish to remove the surface roughness, which also can initiate cracks. And you would have to be sure that the bulk material is really okay, no voids in there, no hollow things with unmelted material. And so you have a lot of uncertainties in the final part. You have uncertainties in the machine, and you have uncertainties in the input material. For example, in purification of the material, when you have oxygen, too much oxygen in your metal powder, so lots of things can go wrong during the melting process, and you don't get the material you would like to get or you are used to get from the machining area, let's say. So we have a lot of questions. Then it's not an unsolvable problem, so you have just to put a bit of effort into it to understand the whole process behind. And we come to the next one. So this is the old area, you know. So we have a big piece of metal. We machine it so that we get finally the form or the shape with the part. And of course, you are producing a lot of metallic waste. You would have to reuse this, and so it costs a lot of money. And this is a big disadvantage. And with the additive layer manufacturing, so you can build an object just with the material you need, more or less. So you build it up layer by layer, and you don't have so much debris. And you have other really big advantages. So you can reduce the material needs and the costs up to 90%. So this is a, well, maximum value, I would say. And you can do, through specific design, also a tremendous weight saving, up to 40%. So the parts, just going back, which you see there on the right side, the part in the background is the original part, and the part in the foreground is the part which was additive manufactured by using a specific design. So where you just leave the load paths, the material where you have the load path transfer. So you can really, for this part, have a weight saving of 60%. This is quite something. Okay, going back again. So we don't want to do this anymore. Of course, the optimum thing would be if you could print everything. And there we have to propose our strategy. So we are at an airworthiness regulator, normally being approached by such a technology, and we don't know that much about. So we have to gather some experience, and we have to rely on the industry to have information exchange, to understand the technology and the processes behind, and the product which is being produced, and its dedicated use in aviation. So this is a very important thing, number one. The second one is we have to identify a potential safety environmental risks. So is there a specific risk on the part when we don't know the material properties, or there's a widespread in material properties? Of course there is a risk, and we have to be aware of this, and we have to try to mitigate those risks. So we are working closely together with the industry to get all those information, to discuss all those things, and also with the NAAs, who are under responsibility of the surveying of the POAs, of the production organizations, who are applying those machines, of course. The further step is, once when we are aware of what are the risks and how can we mitigate, so we have to monitor the evolution. The machines will be developed further. So they started initially, let's say, with a one laser machine for metal melting. So I will just, to make it more easy, to refer to the metal process. There are others as well, so, but it's too less time to explain this. So for the machines, for example, for the metal melting that is being done with a laser system, they started with one laser. In the meantime, we have quad laser machines. So we have 4 lasers which doing independently the melting. And this is a further development, and we have to see if this is, has got an influence on the product as well. And we have to check if our means for mitigation are still effective or not, or if we have to do something more. And that means we have on a frequently basis to review and revise implementation of strategy as necessary. This is in those 5 points our main strategy, first of all to understand and then to track everything and the further development. So I guess one of the main questions from your side is, do we need any new additional requirements to cope with the new technology? So we have to do more effort to show more substantiation, which is, of course, involved by spending more money. And this is possibly not very much appreciated by you. The answer is, currently we don't need new requirements. So our top-level requirements, Part 21, the CSs, are enough. They cover everything. I will come later to the main paragraphs which are dealing with this. And we mainly would like to remind how repairs and design changes have to be done in detail, and what is the impact of AM on design organizations or on product organizations and on maintenance organizations. So this will be explained a bit more in detail in the second part by Alex. The requirements. So the governing rule is the 603 requirement for materials. It says the suitability and durability of materials used for parts, the failure of which could adversely affect safety must be based upon experience and test, conform to specifications, meeting design data of course, and consider environmental effects, temperature, moisture, etc. So this is the requirement we start with. The next two about the materials is, starting with the 605, the fabrication method, and this is the additive manufacturing, obviously a new technology, a fabrication method. They must produce a consistently sound structure, so without any spread of material properties, in the best case. And this is where we have to be sure. So if a fabrication process, such as gluing, spot welding, or heat treating, so the spot welding, or let's say the laser welding process comes close to the additive manufacturing with laser melt methods. So all this requires a close control to reach these objectives. The process must be performed under an approved process specification. And to the process specification we come later. It's also a very important thing. This belongs to the EASA strategy as well, that we are involved in developing those process specification. And we have the B, each new aircraft fabrication method must be substantiated by a test program. Okay, that says all. So when you buy such a machine, it's a new method, you have to do some substantiation. What would be the extent of this substantiation? Well, it would depend on would you like to produce critical parts, safety critical parts for an aircraft, then there's a lot of substantiation, and we would switch to the 613. If you have less critical or non-loaded parts, let's say polymer material in the cabin, kind of armrest cover, well, you would possibly just have to do the fireproof testing, and that's it. So this is not safety relevant if you have there a broken material finally. So that shows a variety of parts. It depends on the criticality. Yeah, for the criticality, most critical parts, so we have really the tough requirements of 613, which says mechanical strength properties and design value materials. Most of them for metallic material, that is being done already. We have the MMPDS, the material handbook, where you have lots of material values in there with different heat treatments and different production ways. So, well, you have the rollings in ST direction and so on. So you have all important parameters for the materials listed there. But on the additive manufactured material, we don't have anything there currently. So this is, for example, one thing where the industry together with the authorities are working on, to have an additional chapter in the materials handbook in the MMPDS on the additive manufactured hardware, let's say, or material. For the 613, of course, when you have critical parts to produce, we have to establish design values on a statistical basis. We have the so-called A and B basis. This is a different confidence level. So you have for the A, confidence level of 99%. So that means when you check the material, the properties should at 99% always be the same when you have hundreds of samples. And this would have to be done for the additive manufactured parts or material as well, so that you would have to do a statistic, produce a lot of samples, do a lot of testing, and to find out if your process is really stable, producing good material. So the other side of this is, to gather experience on this new technology, we just arranging workshops with the industry and with other authorities together. And the first of them were quite generic, just doing presentations to see how far the people are, what are they doing. And we did the first one in 2016. in Cologne and a second one the year after, and it turned out to be a good thing to do it every year. So, and you see the development. So the first two ones were generic to get a rough overview of what is being done with this technology in the industry. And then it gets more specific, similar to this workshop here, with breakout sessions before the presentations, so that all participants can really discuss the points which are very important for them, to discuss their needs. And we've tried to do this as well now, so we've changed to a more specific topic on the additive manufacturing. One of the first ones was 2018 with the machine knowledge and training, so we've invited machine producers and the users, and we let them just put them together and let them discuss, so what are the needs? And we found out for the machine producers, it was very important to know about the requirements in aviation as well, so that they can tune their machines and that they have an understanding for the big need of precision and repeatability of the material. Yeah, you see, so we have done the 6th workshop on additive manufacturing 2 weeks ago here in Cologne. And in the meantime, we do it together with the FAA. So we have a combined workshop in additive manufacturing to harmonize our work at a very early status. And it, I have to admit, so it worked quite fine. And we do it now on a basis that we do it here in Cologne and the other time somewhere in the US. It's being organized on a common basis by both parties. If you're interested, I think for most of the workshops you still have material to download from the EASA website. So there you can see what was the outcome of discussions and what are the presentations, so you can get a rough overview of this. And an additional thing is to be involved into the standardization work. So that means we have to have specifications for the material, for the machine process. And this all has to be discussed with the industry, with the experienced people who are working with the machines. They know what are the bad things you can encounter. And there are some subgroups for the specific specifications. This is a powder specification, the feedstock material. That means you feed the machine with, not with ink and paper, as we know it from at home. So you feed it with metallic powder or polymer powder, for example. And there's a specific specification necessary for this because it's, you have to, for example, you shouldn't mix powders from different batches or lots. This may be dangerous. You should have a powder income control, and you should store the powder accordingly to, well, most of the time moisture is an issue, so you should store it under specific conditions. So all this will be mentioned in those specifications. You have process specifications. That means for the machines itself, the electron beam, EBM, the laser beam melting, the powder bed fusion, the wire, direct energy deposition. Those are the main methods we are using. And in those specifications, it's fixed what are the problems, what kind of parameters you should have constant and control, under control. And then we have the material specifications. Do we have to make a post-processing of the material? For example, there's a very famous hipping process, hot isostatic pressing. For some small voids, which are, let's say, non-really melted powder in the material, for small areas, you can heal this material via post-processing. The hot isostatic pressing is, you do it really at high temperature for 3 hours and under 1,000 atmosphere. You leave the material there. It's short below the recrystallization temperature, and it will be healing, and small voids will be vanishing there. So it doesn't prevent you from doing fatigue tests on those samples as well. But it's solvable, and some OEMs have shown when they put a lot of effort into this, they have a high repeatability, even higher than for castings. For castings we have, you may know, factors we put on those to cover flaws in the material. And for the additive manufactured parts, so some OEMs who put a lot of effort and money into this, they found out if we do so and hold all the processes stable, we even don't need a factor like for casting. So it seems to be a good way. This is what we are working on. The green ones are the published standards from SAE. You can just briefly read. You have powder specifications, laser powder bed fusion process specifications, they're the 7003, and so on and so forth for different materials. You have Inconel materials, you have the most advanced one is the titanium 64, so it's 90% titanium with a bit aluminum and vanadium. Those are already published, so you can purchase them, and if you want to use one of those materials, so the strong recommendation from our side is please go into the specifications and try to work along them. Those forthcoming ones are these here. So they are still not published, but they will come. So we have, for example, a process specification for the electron beam, powder bed fusion, and so on and so forth. So this is something which you can, where you can take some time and just go through it and make yourself confident to it. A further thing is, we try to give you a bit of guidance. So for that reason, we are tracking the technology. We're trying to get some information to be experienced and not to say, well, we can't say something on this because we don't know anything. We know indeed something on this. And in the meantime, so we have issued in April 2017, just 1 year after our first workshop on AM, a certification memorandum, which doesn't invent something new. It just reminds you what our expectations from regulator side, which requirements are the most important. And I've just marked the red ones there. These are the structures requirement because I'm the structures guy. There are some others. We see the engine requirements, we see propeller requirements, we see the Part 21, and so on and so forth. Those are mentioned there, and we have explained why we need those requirements and why you have to put a bit more focus on this and put a bit more effort on this under the light of additive manufacturing. And of course, the purpose and scope of this guidance is that we would like you to really work on our expectations. Yeah, the next step is to update those because we have those guidance materials because we have realized that there may be some issues I've mentioned before with the non-loaded, non-critical parts, so you may not to do the whole 613 paragraph which you've seen with the statistical values, the A and B values, so that would be a bit overdone, of course. And so for you guys, the business has to be going on, and I think so those things, when you classify them as non-critical, can be done under a very, let's say, light way of substantiation. And there we would like to issue some guidance in the new update of the CM. Can't tell you a date when it will come out, hopefully next year, sometimes. So we will make the approach on the criticality, which I've already mentioned, and yes, and the statistical material properties, for them you may get an exemption for non-critical parts and less loaded. This is the idea behind it. And the last slide from my side is We will give you also some guidance for the POAs, DOAs, and the MOAs. There's a possible need to increase awareness of closer relationship between those organizations, because of course there is an interference, so we would like to give some guidance on that. And yeah, and of course to make aware of the existing rules there. And now it's Alex's turn. That was part number 1. Alex will proceed with part number 2.
Thank you, Wolfgang. Okay, after you have seen a little bit of technical aspects of additive manufacture, we'll go now through some DOA aspects. First of all, I would like to show you a short, small statistics. We did, through the DOA team leaders, beginning of this year, a survey. And according to the answers, still a limited number of DOAs are involved in additive manufacturing activities. I've seen earlier when Wolfgang asked you, I've seen a lot of hands on the air, but still that might be not so many DOAs yet involved in additive manufacturing. There is also a large gray part here, so some of you maybe have not yet make up your mind and not provide a feedback to us on this topic. I will come back at the end with, let's say, a recommendation for this. Now, you may ask how a DOA may start additive manufacturing activities, and I took maybe a simple example. Hopefully nobody will recognize your design data here. But yeah, you want to manufacture a part through additive manufacturing, it will be enough to say in the notes, for example, that this part has to be additive manufactured. Maybe the answer is no. So you may need to actually refer a process specification for doing this part through additive manufacturing. And you have seen that from Wolfgang's presentation that this process specification is particularly required in some of the CS requirements, some of the airworthiness code requirements. And if this is the case, then obviously your manufacturing specification, your material specification will become part of your type design. And as such, we are expecting a little bit of more elaboration from the DOA side. You have seen already the additive manufacturing is depending on a large number of factors. And then depending on the particular application, loaded part, non-loaded part, plastic, metallic, different type of processes involved, you may have to come up with a process specification. And I just want to present a few items which might be part of this process specification. Don't take this list as an exhaustive list, it's not. You have to explain what is the scope, what type of additive manufacturing process you are defining, what is the applicability, what are the limitations, for example, what kind of parts, what type of parts you may manufacture according to respective specification. What are the materials? Of course, you will have to refer material specification, but you may have also to add handling requirements for the material, storage requirements, and so on. What is the machine, equipment, and tool used for manufacture, including the machine manufacturer, the type of the machine, calibration, maintenance. Facilities are important as well. The machine environment may impact on the result of the manufacturing process. And then you have to describe the process, the preparatory work, the printing steps, what are the key parameters, what are the post-processing methods you will apply to the particular manufacturing process. And of course, you have inspection and test requirements and some part markings. Again, the list is not exhaustive, it's just trying to provide you a hint on what kind of topics have to be addressed in a manufacturing process specification. You have seen that there are already quite a number of industrial standards available. You may refer in your process specification these standards as applicable. But you may also need, depending on the application you intend to use, the additive manufacturing, you may need to qualify the process to demonstrate that the process complies with defined specification and to demonstrate that the parts can be manufactured in a reproducible way. I want to highlight maybe here that this material and process specification are not only part of the type design, but again, answering to some CS requirements, to some airworthiness requirements, they can be considered also part of your compliance demonstration. And as part of type design, the changes in material and process specification are, of course, subject of changes to type certificate process. Now, I think already Wolfgang mentioned a little bit on interfaces between design, production. There is a clear link. There are specific aspects you need to address in these interfaces, like transfer of design data, generation of the manufacturing data by the production organization, and as I mentioned in the previous slide, the qualification of the additive manufacturing process. This all is done together with the production organization. And yeah, I've seen already, sitting at the table there, I've seen already some of the questions you started to ask. We'll have maybe a little bit of time at the end to address some of these questions. But indeed, there are additional challenges if the manufacture is done under maintenance environment and not a production environment. And we are looking to these aspects, and for the moment, I would say that manufacturing is not, additive manufacturing in a Part 145 organization is not possible according to the current rules we have, but we are looking into this aspect. Now, significant change for a design organization or not? Again, depending on the particular applications in which you intend to use additive manufacturing, there are quite a number of activities you need to develop. And of course, we are looking to have these activities performed according to your defined procedures. So you need to have procedures for defining process specification, for defining material specification, and for qualifying them as needed. If you don't have such procedures, according to the requirements we have in 218247, we will consider that if you intend to introduce this procedure, it's a significant change to your design assurance system. However, even if you have already these procedures in place for defining process specification, material specification, if you intend to use these procedures first time for additive manufacture, I would encourage you to discuss with your DOA team leader and offer us the opportunity to be next to you when you are starting this new activity. Of course, reviewing your significant change for introducing additive manufacturing, we will look to usual topics for this, which is type design definition, configuration control, how you classify changes, how you establish a certification basis, how you use the qualification of the process of the manufacturing process, what kind of testing is involved. You may use supplier as well, so we need to look to the interface with the suppliers, with the production organization, and to look to the training as well, which is important for a relatively new technology which you intend to start activities on. We will work normally together with production, with POA team, which can be an EASA team or an NA team, depending on the case. Some closure remarks. So I would restate the suggestion, the recommendation to contact your DOA team leader and discuss your additive manufacturing intended activities. You may also contact our internal EASA working group on additive manufacturing. You have some contact details there. There are all kinds of discipline, structure, propulsion systems, cabin safety, DOA, POA, maintenance cover in this working group. Wolfgang showed you some of our events which are organized each year, so I would recommend you to follow these events. There are dedicated events where you can, of course, get more information on this topic. And follow also our news, the latest, for example, the latest issue of the J News as a small article on additive manufacturing as well. Thank you. And if we have time, we can probably take a few questions.
Yeah, I think we can take a few questions. Some of them that were asked are already answered by your presentation of Wolfgang's, but there are still a number of questions. I don't know whether, Wolfgang, you want to start, or Alex, we have some on the screen.
Yes, I can take one of them. By the way, within the LOI framework, will there be requirements timeline for additive manufacturer to not be novel anymore in the eyes of EASA? My comment on this is not actually an answer, but it's more a comment if you want. Actually, the novelty is not referring to the agency itself. We are looking to novelty for the respective DOA, for the respective applicant in the respective project. So novelty may still be there for quite some time.
Okay, next one, possibly from Erhan. If requested design part is no structural purpose, just for cosmetic parts. This is what I've tried to explain, so that there are indeed some cases for non-critical, less loaded parts, like the famous coat hanger or armrest covers out of plastic, where you really have reduced requirements to fulfill. So, and this is what we are coming up with in our second issue of the CM. So we will try to give you there some guidance where you have easy certification, let's say, and where it would become a bit more difficult.
I think on the other we touched a little bit already.
Yeah, there's another one. This is from Trevor Jenkins. Process variability, how does everything mean for? Yeah, this is the thing, what I've tried to explain as well. So how you would have to produce the data. This is according to the 613, and if you have, first of all, you do a classification. What do you want to manufacture? Critical, less critical, loaded, non-loaded. And due to this classification, you go, possibly when it's critical, into the 613, and you have to do the A and B basis. This is explained there as well in the AMC material. So you have finally to do a lot of samples and show that your process is stable and the material properties have a confidential value of 99%. So that means almost always the same properties. Another one from Mario Pirozzi. Other than your requirements, are you considering new CRE? Or, well, the CRE will just be taken as a kind of tool to make aware of our CM. So yes, indeed, we have CRE for this. We also have a generic CRE already, but I think it's not available on the, well, it's not officially available for you all, so you would have to contact EASA first and then involve the project certification manager or one of those experts of the AM group, and then we can spread this CRE material to you. And that means you would have to describe in detail what you want to manufacture, as I said, the classification of the part, and then in the CRE will just be written that you have to refer to the existing guidance material, the CM, which is issued already.
Okay, maybe one more question due to the time. I don't know who wants to choose one. The first ones I think were already answered.
There's one, may I take this one from Trevor Jenkins as well? So this is about the repeatability. Well, I think it vanished from the list. The second last. Yeah, exactly. So what manufacturing process variables are critical to establish repeatability for serious production? This is exactly what we try to transfer with the standardization material. That means the process specification, the material specifications, which had been worked out by industry and authority in the SAE working group, and by the way, of course, also in the ASTM working groups. So you would have to take those materials, and then you can see what is being considered as the most critical parameters due to repeatability.
The one on deviations and special conditions by additive manufacturing parts on ETSO assemblies. I don't know whether you can answer to that. We can take that question back and try to answer it offline. Okay, thanks a lot, Wolfgang and Alexandru. And with that, I would welcome Gilles Garouste to represent the industry views. You know, the CCOM is one of the advisory bodies to the agency under the Stakeholder Advisory Board. And we have regular meetings with them. The next one is actually next week. And industry is, you as industry globally are our direct partner, and it's always good to have also direct feedback from you on achievements, on things that concern you. That's why we asked the CCOM, and Jill offered to do the presentation on behalf of the chairman to talk about the advisory board and the CCOM. Thanks, Jill.
Thank you, Marcus. So good morning, everybody. So those slides may not be as fancy as some others, but I have only a single message to pass on, and you will quickly understand it. So I'm working at DOA, deeply involved in trade associations at European, French, and American and international level, and that led me to be part of the ASAB, the Stakeholder Advisory Body structure, of which I am a vice chair. And currently here, when I will speak about the certification committee activities, I will do that as a member of that group. So the content is, they are only 15 slides, so I will explain you where we are today and from where we are coming about those advisory body. I will explain you what are the basic functioning of the SAB, the stakeholder advisory body structure, so it's at your service. Some highlight on the code of conduct, because I would like to stress the fact that those people are working for you and not for their employer or their association. And then I will detail a bit the activities which are undertaken within the certification committee, which is of interest to you. And the other one of interest for you is a design and manufacturing technical committee. And you will understand why it is of interest for you in this workshop. So the legal background, so that's the law, the basic regulation that requires the management board of the EASA to establish an advisory body. So, and this advisory body has to represent all the interested parties which are which have to comply with the regulations, with the European regulations, many of them being prepared by the agency. So, according to the basic regulations, so the management board has made decisions establishing this stakeholder advisory body. I will speak about the industry side, and you will understand that there is also a member states side of this advisory body structure. So years ago, more than 4 years ago. So in the frame of a management board meeting, we had a discussion about reorganizing the advisory body. So you remember that before then we had an SSCC, which was a safety standard consultative committee. Maybe some of you were part of this structure. We had the ESSI, which was the European Safety Strategy Initiative, and we have also the EASA Advisory Board, the EAB. So the idea was to reshuffle those groups into a single structure with a better top-down and bottom-up coordination, and the possibility, when there are issues identified at the lower level of the advisory structure, to discuss that with agency directors or to the management board if needed. A key point for all those participants in this advisory structure is to make sure the community is aware of what is going on, to be transparent, and to be representative of a sector. So just a picture explaining the structure. So on one side you have the SAB, the stakeholder advisory body structure. On top of it you have what we name the SAB plenary. It's around 35 members representing all sectors. I mean unions, pilot unions, cabin crew unions, air traffic controller unions, commercial operators, airsport, manufacturers, EU, non-EU, maintenance organization, navigation service provider. So it's the whole range of companies involved, which have to comply with EASA regulation, are represented there. We have also aeromedicine, and so it's a large list. All that is made public on the EASA website. So below the SAB plenary, we have established a number of committees dealing with specific business. I will detail that on the next slide. You have to understand that we have the industry side of the advisory body under the SAB, and there is a similar structure under the member states, which is named the MAB for Member States Advisory Body. And we have exchanges between those groups, between SAB groups and MAB groups, and with a deep involvement of the EASA people at the level of director, experts, head of department, section, etc. And at the bottom of the structure, so you will have all the groups that are established for preparing safety promotion activities, for preparing new rules, performing data analysis. So yes, it was yesterday. So No, it was today. There was a comment made about having an idea of what is going on other aircraft, so that DOA can comply with the obligation to take a look at other products of similar design. And so they are groups in this structure, which are the collaborative analysis group, which are maintaining risk portfolio, and I think it's a good entry for any DOA to take a look at, so that they can this DOA can discharge the responsibility just reminded by Franz. The structure of the SAB, again, it's the industry side. So on top you have the plenary SAB, and then you have two kinds of groups, which are committees or technical committees. So the technical committees, you have a list of 4. One is missing, it's the drone committee. It was proposed several years ago. Its implementation has been delayed, so maybe the agency is ready now to reconsider its establishment, but we have to address the drone aspects as well. So you have the certification committee. I will detail it later on. You have a commercial aeroplane safety committee, which is populated with people involved in managing safety in organizations, manufacturers, operators, pilots, etc. You have the general aviation committee and the rotorcraft committee. So those committees, they have a role, let's say it's a more strategic role. They should look ahead and not just discuss ongoing rulemaking task just decided or to be close to deliver something. The oversight of the contribution to the rulemaking activities are more on the technical committee side, where you have a list of 5 currently, dealing with aerodromes, with traffic management and navigation service, dealing with flight standards, dealing with design and manufacturing, and finally dealing with engineering and maintenance activities. So now focus on how does it work. So the SAB, which is independent from the agency, has developed its rule of procedure with some key features which are reminded there. So it's about complying with the code of conduct, ensuring transparency, awareness of the community, agreeing on the position and decision. And there is a story behind all those topics. For example, the grid position in the previous setup under the EAB, we had situations where, because a single organization was opposing all the others, so the AAB, the EASA advisory board, was silent. And so we agreed when preparing the rule of procedure that this cannot happen anymore, and that if there is a dissenting view or a minority position, it will be fairly reflected in a position, but there will be a position instead of nothing before. So we have clarified the role of the chairperson, secretariat, contribution of the agency in the functioning of the SAB structure, how meetings should take place, and working arrangement. And finally, one of the novelty was to require all those groups to deliver an annual report. It was never done before. We have clarified the distribution of tasks between the miscellaneous SAB groups, because looking at the slide before, going backwards, you can imagine that if there is an activity dealing, for example, with the rotorcraft committee, it could touch also flight standard technical committee or the DNM, design and manufacturing technical committee. And so we had to clarify who is leading what activities. There is an escalation process as well in case there is a disagreement within the group up to the SAB plenary. The code of conduct, a lot of words, I will go quickly, don't worry. So it's about agreeing in a fair manner and ensuring a balance. So we need to balance the safety benefits, we need to balance the international aspects, the business interests, and the social factors. And so it's a key in the operation of the stakeholder advisory structure. We have to make sure that what is being done is transparent and that the community is aware, and I think we can do better in that respect. We will work on it. It's a continuous activity, and we have to perform some progress. And we have to make sure we are representing the interests of the stakeholders. So this is well, good to say. It's obvious, but another item we have highlighted in the code of conduct is the need for associations which are part of the SABE to make sure what is being done does not stay within that association. So they reach out other company for the sector they are representing. And also there is some policies. If somebody is not complying with this obligation, so that person can be replaced. So in a nutshell, it's a group, it's a structure, it's not a single group, it's a structure of a group as you have seen. It's formal because it is established under the basic regulation, so it's something that has to deliver and it has to exist. So we have to make use of this tool which has been provided to us by the legislators through the basic regulation, and they are all at your service. So I've put there the page of the advisory bodies on the agency website. And so I encourage you to take a look at that page. And I've found that we need to improve it, and that will be done quickly. So now, what is being done within the certification committee and within the and later within the DNM Tech. So certification committee, it has to stay at high level. So we are not discussing a specific rulemaking task unless it's extremely critical one. So the CICOM has to make sure the topics are properly handled by the technical committees. And it's a privileged way of interfacing with the certification directorate management. So at each of the meetings are, well, we have Marcus is attending all those meetings. Rachel, as certification director, is coming at the end of the meeting to understand, to have a summary of the outcome. So it's a privileged way of communication with the management within the certification directorate, and it's not limited to the certification directorate. When we are discussing digitalization, for example, we have people from the resource and support directorate attending the meeting, people from the strategy and safety management directorate coming as well. So it's a tool for you to address issue at the level of the management within the agency. The membership currently is by design limited to approval holders for which the agency is a state of design. So it means that there is no non-EU organization in this committee because we have agreed with them that validation aspects of interest through the signatories of bilateral agreements are addressed in another group outside the SAB structure. So the chairman is François Duclos from Airbus, and the secretariat is ensured by Xavier Vergès, you have seen yesterday, and we are holding a quarterly meeting. So it's a continuous, they are continuous exchange between this group and the agency management dealing with the certification topics. So what has been discussed in the last cycle? So first, to agree on what are the high-level objectives that are shared with the management board and which are also reflected in the EASA document you should have read, which is the European Plan for Aviation Safety. So it's a key document. It has been improved a lot over the years, and it's a document you should take a look at for making sure what is of importance for you is taken into account. If not, then you can ask to the CCOM chairman to take your concern into account, and then we will use all the SAB system for making sure your idea is taken into account in the planning of activities with the agency. So we are focusing currently on what is related to safety, what is related to the level playing field, and what is related to efficiency and proportionality as well. So that's, and then from the activities undertaken in the certification committee and all the other SAB groups, the result is an SAB plenary document which is sent to the management board as a list of topics on which we would like to see progress made by the European institutions. We are also obviously talking about international cooperation, so we are discussing, and sometimes we are just informed, but it's better than nothing, about the progress with bilateral discussion with bilateral agreements with China, Japan, and some other. So it's when on the industry side we see a need for developing international cooperation, so we go through the CCOM so that the agency is aware of that. Another area of interest is what is related to research and innovation. And you may know that currently in Europe, the amount of financing for research activity related to aviation safety are very low compared to what the US are doing. And so, I mean, it's by a factor of 100. So it's quite significant. And so we are trying together industry associations, the agency, the European Commission, the Parliament to improve the situation. And I think there was some progress now, and the role of the EASA in supervising or piloting certain research activities has been recognized, and so we are doing much better. And we also have seen that the agency is recognized by the European Commission for controlling certain of those research activities. You may have seen a call for tender published on the agency website, for example, for there was something about rotorcraft crash survivability and things like that. Another topic of interest to all of you is the famous better regulation approach, which does not mean that we are expecting less regulations. We just expect a corpus of regulatory texts that are agile enough so that we can develop products or change to products, innovative changes, and to have those products entering into service. And we are lucky, I think, on the product certification side, because by the tools laid down by the basic regulation allow the agency to tailor the technical regulation you have to comply with when there is some novelty. So we discussed just before the additive manufacturing, so by chance there is no need for changing the regulation, but if there is a need, for example, let's take another example. When Airbus was developing the fly-by-wire control on the Airbus 320, so that was not at all covered by the regulation. But it was possible to certify such an airplane because we have the special condition mechanism that works, and it's fine. But then the issue is, okay, so I have a nice product that can fly down to the ground even if the visibility is extremely poor, but currently you can certify the product, but you cannot operate it because the operational regulations do not allow for. So the better regulation is all about that. So, and the plenary, the SAB plenary has instructed all the SAB groups to make sure that when there is a rulemaking task being discussed, being designed, to make sure that instructions are given to check whether the hard law, the implementing rules are not too detailed on the technical aspects, and that the guidance material prepared by the agency could not be replaced or developed under a format of an industry standard. So that's a good transition with the next key topic is the EASA and industry engagement in the standard making organizations. So in the area of product certification, it's quite common to refer to standards developed by EuroCAE, SAE, ASTM, now with the new CS23. But there are other areas where we could use standards. For example, after many discussions with the agency, but also the FAA, Transport Canada, and ANAC in Brazil. So the industry has organized itself for developing an international standard for implementing SMS in design, manufacturing, and maintenance activities. And this standard has been developed with an agency involvement, which has allowed the agency to recognize it as an acceptable means of compliance to the regulations which are coming on the matter. And there are other standards being developed, such as so there we discuss the cybersecurity aspects. So you have understood that there will be requirements onto organizations for dealing with information protection, etc. I will not redo the same presentation. And there is a work within EuroCAE for developing a standard that could support the implementation of this regulation applicable to organizations. We discussed previously also the competency and knowledge management, and so we are, at the SICOM again, we are trying to look ahead, and we are trying to anticipate, for example, LOI that may reduce the knowledge by the agency experts on products being manufactured, delivered. And so that's one of the points we have been discussing, and we have made proposal, and we are testing solutions so that the agency experts are kept in the loop, not in the critical, on the critical path, but they are kept in the loop of the development of a product and how it has been certified, so that they keep the knowledge, and they are also other exchange about the competency, and Stefan with his presentation also was clear on the topic. Digitalization is also taking a lot of our time. So what we are talking about is streamlining the exchanges with the EASA. So earlier, when I heard that you are expecting to access in a clearer manner the certification basis of a product for designing a post-TC change, this is coming with digitalization. So there are tools the agency is working on. One is named e-rules that may not in the first step deliver the service just expected, but the plan is to deliver it. And so the SICOM is a privileged tool for discussing the agency on those topics, and much more. So for the SICOM. Then quickly, DMTech. DMTech is more focused on regulations related to product certification, manufacturing, and the organizations behind. So the membership is larger than the SICOM, so they are around 25 members from manufacturers, EU, non-EU, from commercial or non-commercial operators, from the training industry, and even from the sport sector. So the chairman, again, is an Airbus guy, Stéphane Fleury, and the secretariat is ensured by Yori that you have seen yesterday on the scene. So the main missions is supporting the activities related to the rulemaking task. It's providing inputs, for example, when there are discussions about regulatory impact assessment, about the best intervention strategy. So a group like the DMTech is a privileged tool for exchanging with the EASA on those matters. And I think in the discussion we had, the feedback from the SAE meetings, they are activities or they are actions you are expecting from the EASA system that could be taken on board by the DMTech, such as having a focus exchange on the internal monitoring system. So that's a task the DMTech could take on board. The term of reference allows the DMTech to invite guests for a given meeting on a given topic. So I think we have the tool, you have the tool for making sure your concerns are taken into account in the EASA system without waiting for an annual meeting. And you will have your representative in such groups that will be able to track the progress and to have a continuous exchange with the agency for ensuring progress is made between workshops like the one of today. So we don't get wrong. We are not talking only about regulations, because it has been also clearly understood that there are activities such as safety promotion that could deliver the safety improvement we are expecting. And I think we are all advocates that we do not need regulations when the aim can be reached by other tools, less burdensome in some cases. Then what they have discussed, so it's an extract from the annual report. So again, supported regulatory impact analysis for some specific rulemaking task. They have contributed to the preliminary impact analysis. They have provided comments on rulemaking task being designed, being decided in the other preliminary phase before the launching of the activity. As a reminder, so the DMTech is a body through which the agency populates the rulemaking groups when there is a rulemaking group with industry involved. So again, it highlights the need for such groups to be aware of who is interested in what. And key topic, I speak again about the EPAS. It's the European Plan for Aviation Safety. So we are using the SAB structure as a bottom-up tool for making sure the EPAS is addressing the concerns from the stakeholders. And that's all. So I'm saving some time for the lunch. So if you have any questions.
Thanks, Gilles. We got a few questions, but I guess some of them are already answered, but maybe you can go through them. It's not that many.
I think well, the first one is, I was surprised not to find the minutes of the meeting on the agency website, because by the term of reference, the minutes of the meeting should be published. So the list of representatives is already on the website. If you go on the page I have given the address, you will find an Excel file. Well, currently it's a PDF version of an Excel file where you have all the members of all the groups within the SAB structure. So they are not the email address. But I will check with NRE and the EASA whether we could have at least the email address of the chairman and of the secretary of those groups. So, and we have to make sure we are publishing the minutes of meeting as expected by the rule of procedure. So, discussion to come with the agency. Yes, they are STC holders. So in the CCOM for sure, it's I have seen him. It's Andreas. So he's there for representing the after-market business, and he's a valuable contributor. And we will meet next week again during the CCOM. In the ARCOM, I don't know, but Mario, I think you are in the ARCOM. You could tell us whether they are a STC company. Mario Pierdi? No, I don't see. He left already. Back to meeting his wife. Okay, bon, okay. Super Mario has left. Okay. With the CCOM follow-up, yes, that's the proposal I made. Not only the CCOM, but well, we will distribute the actions between the CCOM, the DMTech, and maybe some other groups. But I think it's the outcome of the workshop are very valuable. So I think they are of interest to the agency directly. They are of interest for the SAB, and we will take them on board and for making sure there is a progress in between. And what are the other industry partners, members of SAB? So the FA is not part of the SAB. So the SAB is a European body established by the basic regulation, and so there is no FA in the SAB plenary. FA could be involved in rulemaking activities, but not in the SAB bodies. And in the SAB bodies, so again, so they are representative from, it's a very, very large, they are more than 200 names working in those groups, coming from a variety of companies, so small, large, so it's manufacturers, operators, we have general aviation business, maintenance organization, so that's why they are 200 names. And if you take a look at the file I was talking about with the membership, it's organized by groups. You have the sectors, so the groups are structured by sectors. So we are asking for a given sector, let's say manufacturers, to have 5 representatives in a group, to have commercial operators with 5 representatives, to have unions, 10 representatives, it depends on the subject. And then in these sectors, there are several associations, and they have to provide the number of names with alternate that are required according to the group composition. So there are many industry partners, and I will encourage you to reach out for the chairman of those groups when you have concerns. It's a tool at your disposal. It's a privileged tool. It's an established structure. It is formal because established under the basic regulation. So just use it. It's for you.
Thanks, Gilles, and I think that was a very important message, that structure established under the SAB is there for you to establish a means for you to raise your points via the members. So it's all very formal because it's established under the base regulation. And please look at the website and the link that Gilles provided. There you will find all the details, and if you have questions, you get also in the slides the names of the chairmen from the CCOM or the DMTech. But I think it was a good point and a good question whether the topics raised during this conference can also be followed up by these bodies. And as Gilles said, some are mainly in the DMTech area, some may be more for the CCOM, but we will have to discuss how we will address it. And I think it was a good approach, and we will follow that up. Okay, with that, thanks very much to all of you for the morning session. We can close it and break for lunch. Please be back on time at 1:30. Thank you.